you don't have the algebra tiles, we are going to ignore those. You can take out your highlighter. This is the standard form of the equation. And when you have it in standard form, it's really helpful because P and Q are your vertex. A value tells you if you go up or down, and the A value also tells you how wide or how narrow it is. The standard form is really helpful for graphing. But you could expand it and write it in the general form, and the general form is basically useless for graphing. You know if it goes up or down, but that's it. You don't know where the vertex is. The problem is often we get the general form, which doesn't help us with graphing, and we need to change it into the standard form. And we do this by completing the square. So the example that they have, that we're going to skip this one. This is the first example you have. And this one, you have y equals x squared minus 4x plus 10. This is going to be an easier completing the square. What do we want? We want this form. So first of all, do you notice that the A value is 1? It's going to be 1 there. The A value is the easiest thing to figure out. It's going to be a 1. The 4x, actually, I'm going to write it where I have some more space. I'm going to rewrite the original equation. I'm going to attempt to rewrite the original equation. There we go. And I'm going to keep that part separate and have my plus 10 afterwards. And I'm going to leave room for space here and here. Because just like when we solved equations by square rooting, we're going to use this technique. We want this squared. That 4x is the hint that this needs to be a minus 2. If it's a minus 2 there would have had to be a plus 4 there. But unlike when we solved, we put the spaces on opposite side of the equations. Now my spaces are on the same side of the equation. So if I add 4 to this side, it's no longer equal to what it was before. I have to compensate and subtract 4. Because then what I added in green cancels out with what I subtract in green. But now my equation looks like this. And my vertex is at 2, 6. My A value is 1, so it opens up. Goes over 1, up 1, over 1, up 3, over 1, up 5. I can graph this very quickly and easily if it's in the standard form. So that is our goal. Our goal is to take the general form and change it to get the standard form. And we do that by completing the square. Would you like some notes on steps on this? Okay. So you have room. Yeah, you have room at the bottom of the page 292. We'll give a little title. Steps. Steps for completing the square. Maybe this is with quadratic functions. So the steps for completing the square with equations, when you solve by square rooting, is slightly different than the steps for changing to standard form. So I'll write the steps off on one side, and then we'll do an example on the other side that shows the steps with numbers. Okay? So in blue, our example that we're going to start with is y equals 2x squared plus 8x. that's in general form. You know that it opens up because the a value is 2, but you don't know where the vertex is. Step 1. Step 1, you're going to factor out the a value of the first two terms. So what does that look like? I take the 2 out of the 2x squared. I take the 2 out of the 4x. I leave space, keep the 1 beside. Step 2. Complete the square. So what does it mean to complete the square here? Well, we want this. A is going to be 2. We want this to be something squared. So we would need a number here, and we would need a space there. The plus 4x gives us the hint, we've done this before, that this has to be a plus 2. If that's a plus 2, this first space is a plus 4. The second space is where you compensate. If you add 4, normally you have to take away 4. But it says here, don't forget to multiply by a. That's this part. I'll underline it in red and color code it there. What have we actually done by putting a 4 inside the brackets? We've actually added 8 to the right-hand side. So to compensate, I need to subtract 8. And now, -1 plus 8, that'll be minus 7 there. So those are our steps. We have to factor out the a out of the first two terms. Maybe put in green there. I also set it up with the green spaces right away. And then we can complete the square. And in completing the square, we have to be careful with the last space. Because when we compensate, that number might be different. That never happened when we solved. When we solved, the spaces on both sides were always the same number. Now they could be different. So it's slightly different method from before. So let's go to example 1. Was everybody done? Did I go too fast? You were done?
No.
No? Okay, I go too fast. I went too fast. So we want to find the vertex. If we want to find the vertex, it would sure be nice if it was in this form. So what do? We factor out the 3, that's your a value, out of the first two terms. And we leave a space to set ourselves up to complete the square. The -4 is the hint that it would have to be x minus 2 squared. What would be in your first green space then as a result? there would have to be a +4 here. What would we have to do to compensate? -12, giving us a -5 here. So our vertex, now that it's in this form, is 2, -5. So very similar to solving equations, but a little bit more complicated because the spaces are on the same side, and when you compensate, it might be a different number. I'm going to give you some time now to try some of these. Circle 3, 4, 5, and 6.